So right here, it says find the length of the side of the square garden. All right, so if I actually want to start by defining my variables before I even start, that's a good way to do it. I'm going to define x as being the length of the side of the square garden. Okay, so I'm going to let x equal length of the side of the square garden. Which naturally, we probably just would have drawn the two gardens and would have put x on that side anyway. However, it's always good to define that variable first. Okay, now we're talking about a square garden. Okay, so we know we're going to have a picture of a square. All right, and about a square, what? We know all four sides are equal, so technically I could label it like such from geometry. All right, I've got a rectangular garden as well. Scroll it down here. Kind of got kind of big there, but all right, okay. All right, now we're going to, and we said that we were going to let the side of the square be x. So that means this side is x, this side is also x. I'm not going to go all the way around, but that's x. Okay, now the length, I'm going to color code this, the length of the rectangular garden is 5 feet more than twice the length of the square garden. Okay, so that part right there is going to give me the length of this rectangular garden. And I need to focus on the 5 feet more than twice the length. All right, so twice the width of the square garden, and then 5 more than that. So the length of the rectangle has got to be a 2x plus 5. All right, then it very clearly identifies the width of the rectangular garden, and that is 6 feet less than the side of the square. All right, so now I can use that sentence and define the width. I need to focus on this part right here, 6 less than the side of the square. So that's just going to be an x minus a 6. So now I have this dimension and I have this dimension. Okay, from there, I have to write an equation. All right, the square garden and the rectangular garden have the same area. So that first part is what is going to tell me how to write the equation. All right, if they have the same area, I know the area of this rectangle is length times width. I know the area of the square is length times width, side squared. All right, and they have to have the same area. So I'm going to set those two areas equal to each other. So that's going to be my equation. So my equation that I'm going to write, all right, the area of the square, x times x. So I'm just going to go x squared. That's got to be equal to this area, length times width, area of this. So a 2x plus a 5 times an x minus 6. I'm not going to try to multiply that out right there. All right, so actually that's the original equation before I start simplifying it and moving everything over. Okay, so there's the equation. Left-hand side, not going to do anything with that because it's just an x squared right now. This side over here, I'm going to FOIL it out. So showing all the steps, 2x times that x would be a 2x squared. 2x times the negative 6 is going to be a minus 12x. Inside terms would be 5 times x. Last terms will be the minus 30. Okay, now on this one, obviously I've got some like terms here in the middle that I can combine. I want my leading term to remain positive, so I don't want to move everything to the left. I'm going to move this little guy to the right. That way this will stay positive. So I'm going to subtract x squared and subtract x squared from both sides. It's going to fall out on this side. All right, that ensures that I then have a leading term that's positive, makes it easier to factor. So I would have a 0 there. Subtracting there, I'm going to have just an x squared. Putting these two together, I'll have a minus 7x and then a minus 30. So believe it or not, we still ended up with that quadratic. Almost all these story problems are going to be quadratics. All right, no greatest common factor on this one. So I can just start the guess and check process. Got that leading coefficient of 1, which makes it relatively easy. All right, let's see. Oh, I don't know. 10 and 3. 10 times 3 is 30. Okay, at this point, hopefully we're getting really, really good where you can just kind of do that in your head. All right, 7 is negative, so I want the 10 to be negative. The 3's got to be a positive. I get unlike signs to get the negative 30. Subtract to get that negative 7. Setting everything equal to 0. The x equals negative 3 on this one. The x equals 10 on this one. And again, it's wanting the length of a garden. A length dimension cannot be negative, so we have to throw this one out. So it's got to be 10. All right, now, does that answer the question? Find the length of the side of the garden. We said x was the side of the garden, so yes, it does. All right, so side of garden, 10 feet. I think it's in feet. Are we in feet? Yep, we're in feet. So 10 feet.